Hello, my name is Anirudh. I am from ITI and my roll number is 22BQ1A1233 and my topic is breadth first search, which is a graph traversal technique and it uses queue data structure, and I am going to explain it with the help of an example. So let us consider a graph with 5 vertices. So let this be the graph that we are going to traverse using the BFS algorithm. So first of all, we are going to use queues in this breadth first search algorithm. So we are going to declare a queue of size which is equals to number of vertices. So here we can see that there are 5 vertices. So I am going to declare a queue with size 5. So initially, as you know that in a queue both front and rear are pointing to -1. So now let's take the vertices. So in BFS, we have to visit a vertex only once to prevent loops. So I'm taking an array called visited and which denotes if the vertex is visited or not. So I'm initializing all the vertex visited value with 0, which tells us that none of the vertexes are visited at least once. So let us consider a source vertex. So here I am considering V5 as my source vertex. So when I visit source vertex V5, I will make its visited value as 1. And then I am going to push it into the queue. So here the front and rear are updated to here. So now I am going to visit all the adjacent non-visited vertices of the vertex which is at the top of the queue. Okay. So here as we can see that V1 and V3 are the adjacent vertices which are not visited. So we are going to visit them in an order. So we can easily represent them using an adjacency matrix while coding. So here I visited V1. So I am updating the visited value to 1 and I am pushing it into the queue. And now I am going to visit V3. Here I updated the value of visited to 1 and I pushed it onto the queue. So the rear used to be here. Now as I pushed it, it has been updated to 2. Now as there are no other vertices, non-visited vertices adjacent to the top of the queue. So we are going to pop the top of the queue and add it to the BFS. So this would be our BFS algorithm result. So here as there are no adjacent non-visited vertices, I am popping V5. Now front points here and here I added V5. Now at the top of the queue is V1. Now I am going to visit all the adjacent non-visited vertices of V1. As you can see, only V2 is V2 is the non-visited vertex of V1, adjacent vertex of V1. So here I visited V2, I made visitor of V2 equals to 1 and I am pushing it onto the Q or in Q. So as there are no other non-visited adjacent vertices to V1, I am popping and adding it to the BFS. Now at the top of the Q we can see that V3 is present, and now I am going to visit the non-visited adjacent vertex of V3. So here we can see that V5 and V4 are the adjacent vertices of V3, but we can see V5 is already visited since the visited value of V5 is 1 and V4 is the only one that is not visited. So I am going to visit V4 from V3. And here I updated the value of visited of V4 to 1 and I am pushing it onto the Q. So there are no other non-visited adjacent vertices to V3. So I am popping it from the Q or dequeuing and adding it to the BFS. Now at the top of the Q is V2. As you can see here, V2 has adjacent vertices V1 and V4, but both of them are visited. So there are no unvisited adjacent vertices. So I am dequeuing V2 from the Q. And I added it to the BFS, and at the top of the Q is V4, and V4 we can see that V3 and V2 are the adjacent vertices and both of them are visited. So I am dequeuing it from the Q. Since front and rear are pointing to the same location, I am updating them to be -1, which means that the Q is empty. And here I added it to the BFS, and we can see that the BFS order is V5, V1, V3, V2, V4, and when we remove all the unused edges from the graph, we can see the spanning tree. This is the final spanning tree and this is the BFS result. Thank you.